So our final video for operations with radicals is about rationalizing the denominator. So long ago, some mathematician made a decision that we do not like having square roots in our denominators, in our fractions. So to counteract that, what we do is we do what's called rationalizing the denominator, which is getting rid of that square root symbol or third root or fourth root symbol. And it's a pretty easy process on doing it. We're just going to use one really big, really important theory of mathematics, and that's that identity property, that if we multiply any number by 1, we don't change its value. So let's take a look at the fill in the blanks here for rationalizing the denominator. So a couple things for the fill in the blanks to think about when we rationalize the denominator. The first is that multiplication identity property, where if we multiply a fraction by 1, we don't change its value. The second is that any expression divided by itself is equal to 1. So like 3 over 3 is 1, 4 over 4 is 1, like 2 over 2 is 1. Okay, so those are very important things, because what we want to do is we want to work with these numbers, these fractions. We don't want to change the value of the fraction, we just want to change the way it looks. So let's take a look at example 1 and see how we do that. So to get rid of a radical in the denominator, we multiply the numerator and denominator by the radical in the denominator, right? So what I want to do is I want to get rid of this square root of 2, okay? But I know that whatever I do to this number, I don't want to change its value. The only way to do that is by multiplying it by 1. Okay, now that 1 can look very different. Okay, so I don't want to change the value, just the way it looks. So the trick I use is I multiply it by the square root of 2 over the square root of 2, because this is 1. But by choosing 1 to be the square root of 2 over the square root of 2, I'm going to change the way this looks. So let's see what happens. On the top I've got 8 times the square root of 2, so I just leave that as 8 square root of 2. And on the bottom I have square root of 2 times the square root of 2, which is the square root of 4. And that's handy because the square root of 4 is just 2. And then I can simplify that even further, which would be step 4 here, because 8 over 2 is 4. Okay, so there's my trick. I'm multiplying it by 1, but the 1 is really square root of 2 divided by square root of 2. Okay, let's try doing example 2. For example 2, we have 3 divided by the square root of 3. So again, we have a square root symbol in the denominator. We don't like that. So we have to change the way this looks, but not change its value. So in order to do that, we are going to multiply it by the fraction square root of 3 over square root of 3. And that's going to give me, in the numerator, 3 square root of 3, and in the denominator, the square root of 3 times 3 is 9. So then I have 3 square root of 3 over the square root of 9 is 3. And then you can see that when I simplify again, 3 over 3 is 1. So I have the square root of 3 as my answer. So it's kind of a funny one. 3 over the square root of 3 is the square root of 3, because square root of 3 times the square root of 3 is 3. Okay, so it kind of works that way. So I thought that was a cool example how 3, dividing it by the square root of 3 just gives you the square root of 3. And now we'll move on to example 3. A lot of 3's. Our very last example, we've got 2 square root 3 divided by 3 square root 15. So first we have to do some work with dividing it. So we want to simplify this problem. So with dividing with radicals, now that you have some practice with that, remember we write this as one big radical. So it's 3 over 15. And then I reduce that. I can't do anything with the 2 over 3. But reducing 3 over 15, 3 goes into both of those, so I'm left with 1/5, which is then 2 square root 1 over 3 square root 5. And we don't really need this square root of 1, so it's just 2 over 3 times the square root of 5. And now, again, we don't like having this square root symbol into our denominator. So, what do we have to do? Well, now we have to rationalize. So let's bring this down here. 2 over 3 square root of 5. And let's use another color because we have kind of another process that we're doing. I don't want to change the value of this. I just want to change the way it looks. So I'm going to multiply it by the square root of 5 over the square root of 5. Okay. Don't be deceived by this 3 here. I wouldn't do 3 square root of 5 over 3 square root of 5 because I'm not concerned about the 3. It doesn't have a square root symbol with it. I'm only concerned about changing this 5. Okay, so let's see what happens when I do that. On the top, I'm left with 2 square root 5. And on the bottom, I've got 3 times the square root of 5 times 5, which is 25. And this further changes, because I've got 2 square root of 5 over 3, and the square root of 25 is 5. And I just keep going with my simplifying. The top stays as 2 square root of 5. And the bottom, 3 times 5 is 15. And there's my final answer. No square root symbols in the denominator, so I'm all set. So now that you've finished with the foldable, you're going to do the last 2 problems of the practice page. That's 7 divided by the square root of 7, and number 5 is 4 square root 5 divided by 3 square root 15. And to put this into your book, you're going to start with the front, which was adding and subtracting radicals, and you're just going to take a piece of tape and you're going to put it right here to make a page within a page. And I'll do that now so you can see what it looks like. So we're going to be able to flip it open, but still see this back where we did the rationalizing the denominator examples. And there you have it. So your next step is to do these 2 practice problems, number 4 and number 5. And that's it for this entry.